Hello folks, and welcome back. Today we're going to be covering a really cool topic, actually, in my mind. It's two variable inequalities. So to get started, I want us to think about some of the information we know about normal inequalities. Specifically, how many solutions are there to an inequality? And also, how did we distinguish something like a less than sign from a less than or equal sign when we were graphing? So for this first one, how did we do this? If we were to say something like x is less than 1, well, how many solutions are there? It could be 0, it could be minus 1, it could be anything all the way out till minus infinity. So our inequalities will always have infinitely many solutions. Shorthand that to IMS. All right, how did we distinguish between less than and less than and equal to, or greater than and greater than or equal to? Well, to do that, we made an open dot for a less than sign and a closed dot on our number line for a less than or equals to. So we'd have something like that versus something like this. So looking at these, we only have one variable in these. Now we're going to move on to two variable inequalities, or a system of linear inequalities. And all a system of linear inequalities is an inequality based off the graph of a function. It's an inequality based off the graph of a function. Great, so let's dive into two variable inequalities. Here's how we go through the process of solving one, or getting the graph of one. Our first step is going to be graph the equation like there was an equal sign. So graph like an equal sign. And there's just one key distinction here. Here we have to be looking out for whether we have just a less than or a less than or equals to sign. In this case, we just have a less than. We'll get to that in a second. So how do we graph this? Well, it's negative 1/2 x plus 4. If this was y is equal to negative 1/2 x plus 4, we'd go all the way up to 4. We'd go down 1 over 2, down 1 over 2, and we'd have our graph somewhere along this line. Now, because we have a less than sign here and not a less than or equal to, the way we're going to distinguish this is instead of drawing a straight line, we're going to draw a dashed line along this. So with a less than sign or a greater than sign, we have a dashed line. With a less than or equal to, or a greater than or equal to, we have a solid line. And we'll explain why that is once we complete this up. Now, step 2, just like in a normal inequality, we're going to test a point. So for this, we're going to test a point. I always like to test the point 0, 0, because it means we have to do the least amount of work, right? Don't need to throw anything in except for zeros. Let's put that into our inequality, see if that comes out true. We get 0 is going to be less than minus 1/2 times 0 plus 4. And is that true? Well, we have 0 is less than 4. So that is true. That's good. What we do from there, we've tested our point. Step 3 is going to be shade, just like with a normal graph. Except for this time, we're going to shade a whole region. I like to do solid line shades, and I recommend you do those as well, because we'll be getting into sometimes we'll be looking at multiple inequalities. We'll have to be able to distinguish which one we're looking at. Okay, great. So now why did we make this a dashed line instead of a solid line? Well, in the same way that the solid line meant this was equal to, the dashed line is a way of reminding us anything on this side up to this line, but not including it, will work. So if we chose a point right in here, that would work. Right in there, that would work. But if we get to the actual line, that's not going to answer our question. And that's why we dash it. when we just have those less than or greater than signs. Great, so that's really all there is to solving in two-variable inequality. We're going to do some more practice, but just remember your steps are: treat it like you were trying to graph if it was an equal sign, test a point, and then shade accordingly. So let's go into another one of these. For this one, we have 4x minus 3y is less than minus 12. Right, how would we do this if it was 4x minus 3y is equal to minus 12? Well, we'd have to solve for y. So let's go ahead and do that. We'll subtract the 4x, we get minus 3y is less than minus, what would that be? Minus 4x minus 12. And now we're going to divide everything by minus 3. Here's the part where we have to be careful. We're dividing an inequality by a negative. What happens when we divide an inequality by a negative? We have to flip this sign. So that's another thing we have to be on the lookout for when we're doing these. This becomes then y is greater than minus 4, actually that's positive 4 over 3. Negative times a negative is a positive. So it's 4 over 3x. Now, minus 12 divided by minus 3 is going to be plus 4. Perfect. Now let's graph that line. So we start at positive 4. We're going to go up 4 and over 3. 1, 2, 3, 4 over 1, 2, 3. Let's make this as complete as we can. We'll go the other way. Down 1, 2, 3, 4 over 3. Down 1, 2, 3, 4 over 1, 2, 3. And we'll do that once more. Down 1, 2, 3, 4 over 3. Here's our line. Now, is it going to be a dashed or a solid line? To do that, we have to look at this inequality. We don't have an equal sign on here, meaning that we are good to just have this be dashed. Let's dash this line. And now we have step 2 done. We've made our line. Now we have to test a point. Let's look at 0, 0 and see whether that's true. Is 0 going to be greater than 4/3 times 0? So 0 plus 4. 0 is not greater than 4. That makes us sad, meaning that this is not true. What happened with a normal inequality? When we tested a point and it came out wrong, we shaded the other side. So that's what we're going to do here. We're going to shade the other side as well. And that's our graph. Now we're not just going to use linear graphs. A lot of this is actually going to deal with absolute values as well. So we're going to have to pull on that last lesson where we were learning about how to graph absolute values. This absolute value looks pretty normal except for this plus 4. What's that plus 4 going to do? Well, it's outside of the absolute value. It's on the very end, so it's going to move us up 4. Let's go ahead and do that. So we go up 1, 2, 3, 4. Looks like our numbers are normal, so we're just going to go up 1 over 1, up 1 over 1 to each side. And this one again is not equals to. So we're going to dash this line. There's step 1 out of the way. Step 2, test point. Let's test 0. Is 0 going to be less than the absolute value of 0 plus 4? Absolute value of 0 is still 0, so is 0 less than 4? It is, meaning that we get to shade the side that we tested. So make sure you're shading in some way that makes sense to you, but it is also neat that you can also recognize it and recognize if there's going to be multiple graphs. There we go. So that's the basics of finding an inequality or graphing an inequality from a function. Let's do it in the reverse way though, because we can also look at a function or a graph and find the function. We're just going to do the same steps. The first thing we're going to ask is, what's the graph of this line? Well, this looks like it's going to be an absolute value function of some sorts. So we're going to have an absolute value of x. Where's this been shifted? Well, we've moved to the right 2, and we've moved up 1. And from there, it looks like we're just going up 1 on either side. So we've moved right 2, and we've moved up 1. So the right 2, we put it in absolute value. That moves to the right. That's the flips, so we get minus 2 plus 1. And that's the equation of our line. Y is equal to the absolute value of x minus 2 plus 1. But now we have to include this shaded region. For starters, looks like this line is solid, meaning that we can just call this, we know that there's going to be an equal sign here, but what about the shading? Is it above or below? On this one, we're underneath it, right? We're looking at everything smaller than this function. All the values are less than this function, meaning that we're going to have a less than sign. And that's all we need. We have our equation. We know that we're going to be equal to, and we know that we're going to be less than. And now we can just combine this all together to get y is less than or equal to the absolute value of x minus 2 plus 1. Great. We have a little bit more practice here just to make sure we're comfortable with it. For this one, I'm going to leave this for you all to practice, do on your own. But what about this one? Well, we're looking at, it seems to be an absolute value function. We've moved over 1, 2. So we've moved left 2, and we've moved down 2. So we're going to get y. Normally this would be equal to, but we have a dashed line here, so we don't even get an equals to. What is the equation going to be? So it's the absolute value of x. How do we move this left 2? We're going to add 2 inside of the absolute value. How do we move it down? We're going to subtract 2 outside. And finally, we have to determine the sign. This one's dashed, meaning that it's not going to be equal to. And is it above or underneath? It's underneath. All of our values are smaller than this graph, meaning that we're going to need a less than sign. So our answer is y is less than the absolute value of x plus 2 minus 2. And then finally, one more of these for practice. We have this line here. Now it's just a line, so we have to remember how we do a line. Looks at, we have our y-intercept at 3, and if we're looking for a point, looks like we might have a point up here. It's a little harder to see on this graph. That might work. So let's see how far we go up and over. We go up 1, 2, 3. We go over 1, 2, 3, 4. So it looks like our y-intercept is 3 and our slope is 3/4, meaning that this would normally be y is equal to 3/4 x plus 3. But we're no longer dealing with equalities, we're dealing with inequalities. So now we have to see which sign goes in here. It's dashed, meaning that we have no equal sign, and it's everything underneath. It's everything smaller. Smaller means less than. So the equation for this line is y is less than 3/4 x plus 3. So this is the basics of two-variable inequalities. Where might these show up, though? Well, let's think about this in terms of something that might show up in the real world. Let's say you have $15 to spend at the fair. Maybe next year when the fair will be coming back. Now, normally the tickets for the small rides, apparently we're in 1980 actually based off of these prices, is 75 cents, and the large rides are $1.25. So we're trying to figure out what the total number of rides we could go on in any situation would be. Let's say that our small rides are going to be x, and our large rides are going to be y. Then we could make this an equation, a two-variable linear inequality, just based off of this information. We know that the amount of $75 tickets we get, plus the number, or 75 cents, plus the number of $1.25 tickets we get, will have to be less than or equal to 15 bucks. Because we can spend up to 15 bucks, we just can't spend any more than that. And look, it's our favorite friend, standard form. So from here, all we need to do is we need to solve for y. So we could just subtract this 0.75x over, we'd get 1.25y is less than or equal to 0.75x plus 15. And then we're going to divide by the 1.25. Let's pull out our calculators, see how that goes. So we get 0.75 divided by 1.25. We find out that y is going to be less than or equal to 0.6x plus, this should be minus, and 15 divided by 1.25 is 12, plus 12. Or you could just do this using your intercepts. Either way would work. But from here, we could actually just make our graph. Where we look at this, we say this is our tickets for small rides, tickets for small, and this is our large tickets. We know we can get up to 12 of these, 2, 4, 6, 8, 10, 12. And we would have to do the intercept the other way. But what we know is we go down 6 for every 10 we go across. So I don't know how many of these we'll need. Let's just actually find the intercept. That'll probably make our lives easier. So for finding the intercept, this would have to be 0.75x is equal to 15. Or our x-intercept will be 15 divided by 0.75, 20. So we can get up to 12 large tickets, or up to, we'll go 5, 10, 15, 20. And now what we can say is, well, we have a point here, we have a point there, and we know we can spend up to that $15. Anything less than that is fair game. And so this will give us the total amount of rides that we can get on for small rides and large rides that we need. Right, there's our lesson on two variable inequalities. Let's go ahead and get you started on your homework.